In the previous lesson, we were looking at how the Pythagorean theorem can be used to find missing lengths in right triangles. This lesson is going to be fairly similar, with one key difference. We're not simply going to be given a single triangle to find a missing length for. These are what we call multi-step problems because it takes multiple steps of working in order to get the solution we need. Now, what I strongly recommend you do here is don't watch this video all the way through. Each time we get to a problem, pause the video and see if you can figure out how to solve it yourself, because that exercise of thinking through the problem on your own will do you much better good than what I can do by describing the problems for you. But now I'm going to go through and solve the first example. So you can see that we have two right triangles here, and they're attached by this common side. Now, the side we want to know here is labeled X. Now, if we only had this right triangle, this is a problem for us, because to find an unknown length, we need to know the other two lengths. But we don't know what this length is. Well, actually, that's not too much of a problem for us, because we do know these two lengths. If we know these two lengths, we can find what this length is as the third side of the right-hand right triangle. And then the left side right triangle will then have two known sides, which means we can find the third side, which is the side that we want. So let's use a variable for this side here. I'm going to use y. I don't want to use x because x is already being used in the problem. So now we can use the Pythagorean theorem with this triangle on the right. So we know that the two legs squared, which will be y, and 10, add their squares together and we get the hypotenuse squared. So that will be 13.5 squared. So we can evaluate here these two squares. So y squared plus 100 is equal to 182.25. Subtract 100 from both sides, and y squared is 182.25. Take 100, which is 82.25. That means y is the square root of that number, which is approximately 9.07 inches. Now that we know y, we can use that to help us figure out what x is. So 4 squared plus y squared equals x squared. Now the reason I've written it like this is we don't actually need to use our 9.07 because we already know what y squared is. It's 82.25. So 4 squared is 16. Y squared is 82.25, and we don't know what x is. We can add those two numbers together to get 98.25, which is equal to x squared, which means that x is the square root of 98.25, which is 9.91 inches. So this is a fairly common multi-step problem that we get. We have two triangles attached to each other, and we're missing one length that would let us solve for the length we actually want to know. So you need to solve using the other triangle to help you find that missing length that you need to use. For the next problem, we'll take a look, and remember, pause the video, see if you can figure this out on your own before we actually solve it together. Now you might be looking at this and going, where on earth is the right triangle? We need a right triangle in order to use the Pythagorean theorem? Well, it's hiding as part of the trapezoid. So if we get my ruler in the right spot, draw a dotted line through there, what we have here is a rectangle and a right triangle, assuming that we've drawn that at a right angle, which was the intention. Now, why might we want to use the Pythagorean theorem here? Well, we want to find perimeter. And perimeter is the sum of all the lengths around the side of our polygon. Well, we've got 5 centimeters here, 8 centimeters here, and 16 inches. I'm not sure why that says that. That should probably say centimeters. But we've got that length there. But what we don't have is this angled length here. But by turning this into a right triangle, that's now a hypotenuse. So let's call that x for now. That's the length that we don't know. So what are the other sides of this right triangle? Well, hopefully you can see, because this here is a rectangle, our dotted line here has to be the same length as the other side of that rectangle. So that is 8 centimeters. Now the other side of our right triangle is this one here. Now it's not 16 centimeters because that's the distance all the way across the bottom. But because we know that this part here is 5 centimeters, the other part of it must be 11 centimeters. So that means we now have 2 of our 3 sides for our right triangle. So we can use the Pythagorean theorem to find the third one. So we square our 2 legs and add them together. That equals the hypotenuse squared. 8 squared is 64. 11 squared is 121. That still equals x squared. Add those together, we get 185. That means that x is the square root of 185, which is approximately 13.60 centimeters. Now the perimeter, remember, is what we're actually being asked to find in this question. So the perimeter is what we get when we add all the sides of our polygon. So that would be 5 and 8 and 16 and x. So 5 plus 8 plus 16 plus 13.60. So that ends up being 42.60 centimeters. For the last example, again, take a look at this and see if you can figure out how to solve it first. So if it isn't clear, this is a 3-dimensional figure. It is in fact a rectangular prism. And we have a diagonal going from one corner to the opposite corner. So it might not look like there's many right angles, but remember, this is just how we draw a 3-dimensional shape in 2 dimensions. There are right angles all over the place in the corners of all these different faces. But where is the right triangles hiding? Where are the right triangles hiding? Well, we can find a couple of right triangles by adding another diagonal, but not a diagonal of the whole box, but a diagonal of the bottom face. So by doing this, we have this triangle on the bottom face, and let me just draw in my right angle sign there. And then we have another right triangle. We have a right triangle formed by that second diagonal and this vertical side here and the diagonal of the whole box. So let me draw that in as a right angle. Now remember, they don't look like right angles, but if we remember that this is really just a projection from a three-dimensional shape, those are actually right angles. So we really have two triangles going on here. So we've got the one that's along the bottom, which has sides 4 feet, 2 feet, and I'm going to call this x since I need another variable, and we've used d for the main diagonal. And then our other right triangle has that length x along the bottom, and then it has a height of 1.5, and then d is that main diagonal we don't know. So 2 squared plus 4 squared equals x squared. 2 squared is 4. 4 squared is 16. That means that x squared is equal to 20, which means that x is the square root of 20. And I could work out what that is. Actually, I will. It's 4.47 feet. We could pretend I just typed that into a calculator really quickly. What I really did was had it worked out ahead of time. And then for our other triangle, we can now use this because we now know what x is. So x squared plus 1.5 squared equals d squared. Now we know x squared is 20. So we don't actually need to square 4.47 because we already knew what x squared was. 1.5 squared is 2.25. And we still don't know d. This means that d squared is 22.25. And d is the square root of that, 22.25, which is 4.71 feet. So there you go. Sometimes problems that don't appear to have right triangles in them actually have right triangles hiding all along, and it just takes a little bit of work and the Pythagorean theorem to be able to solve those problems too.